here's the thing. Look, when you actually are doing a reaction, obviously the substrate is going to get consumed, right? So the substrate concentration is going to go down, obviously, okay? But here's the thing. Depending on um, the order of the reaction, one of these three scenarios can happen. So again, so they're all time, so that's really not a difference. This is a super important thing. We're going to be practicing this plenty today. And yeah. So um and then what was going to happen is, so it's going to be, let's say our substrate is A, like the reactant. And this would be ln of A, and this would be 1 over A. Okay. So look, again, as you have worked with Excel, like, or everything has a trend line. So it doesn't mean like all the your data points have to be on the trend line, but they all have a trend line. And because the A is getting consumed, obviously the trend line would be down. It goes down. Same thing with here. And then it would be going up because again, it's 1 over something that is actually declining. Okay. So now here's a beautiful thing. Depending on which one of these three you get data points on, like their trend line, like, because again, the data points can be all over the place. But depending on whether the reaction is 0 order, first order, or second order, all of the data points will be on the trend line of one of these and all over the place for the other ones. That's what it is. So that's actually how you can actually figure out the order of a reaction based on which one of these three your data points are on the trend lines. So for example, if the one that you get the data points on a trend line exactly is the A over T1, like the first one, well, you see the other one is like this. This indicates that the reaction is 0 order. Like literally. And we're going to do stuff with this later. If the one that you get things like the number of data points are going to be on this straight line one is this one, then this means, well, the reaction is first order. And if the one that you actually get data points on is this one, so that will be, mean it's a second order. Again, like all of these three diagrams are given to you though, and they're going to add a bunch of random ones, which I'm going to show you in a bit. So depending on which one of these three, again, they're going to give you like Van Hoff equation too, like, and sorry, Van Hoff diagram too. You're like, why would they give you Van Hoff? To distract you, to do, because you need to know which of these three diagrams you should be looking for. They're not going to just give you three and ask you questions. They don't have to. So you need to know what to look for. So depending on which one of these three you get the data points on the diagram, that would tell you the order of the reaction. And then of course we're going to go forward with what I'm going to talk about. So an example of this is actually from another university student. Did I delete this picture? Okay, 1 second. I just want to show you like because he actually got the real data. So that's why I want to show you. There you go. So he actually ran his data, like actually, that was his real data. And you see that's like the concentration of its like A over T, and this is the what is this one on? He didn't, oh yeah, so he didn't label the y-axis properly. But this one is like 1 over A, this is the ln over A, and this is the A. So you see the data points are not on the point for the zero order one, the A over T. But for the ln of over A1, all your data points are on the trend line. And then it's not for the second one, for the last one, I mean, which is second order one. So based on this, we know that this is a first order reaction. And then now that we know it's a first order reaction, we're going to use its like slope and other things to solve for things. So that's kind of like how you approach these. Yeah. So now we're going to come up with like linear algebra is this. So what we're going to do, so you're like, okay, so again, all of these diagrams that are given to you, they have their own slope and y-intercept. But for a given question, you only use the data points from the diagram where your data points are on the trend line. Like, for example, if it's a zero order, I'm not going to use these. These are like not helpful. I'm actually going to use this. So where y is equal to mx plus b, your m would be minus k. Why minus k? For a very simple reason. Your slope is negative and your k is positive. So you need a negative times negative to give you a positive k. And your b would be your A naught. That's the concentration that you started the reaction with, your initial concentration. Yeah. So technically, you can actually write this equation as, and this is given to you on your formula sheet. AT, which is your concentration of the A at a time t, would be equal to minus KT plus A naught. Easy. Yeah, that's it. Mhm. If it is a first order reaction, then I can, well, I mean, I don't have to, just say it's ln. There you go. Where this is actually, so again, when we have a y is equal to mx plus b, the m is still a negative slope. It's always a negative slope. It's minus k, but pay attention, b is not your, this is a very common mistake. People think because the b of this one is a naught, the b of this one is a naught. No, it's a ln diagram. It would be ln of a naught. The y-intercept would be ln of a naught. And again, you can actually write this equation in two ways. You can say ln of a t is equal to minus kt plus the ln of a naught, or you can actually write at over a naught is equal to e to the power of minus kt, I think. Let me double check. It's actually, these are given on your formula. Yeah. So that's like for zero order, that's for the first order, and that's for the zero order. So again, the reason we kind of like go with both, I'm writing this because so you can see that this is kind of the same as the last one, but it's based on ln. But what is the t mean? Oh, time. Time here. Yeah. Because again, you're trying to calculate what your concentration will be like a certain time later. And oh, actually, I'm so glad you asked that question. So the time that is given to you and the K, you remember the K is per unit of time. Remember, like it could be 1/molar time. Again, it could be per second, per minute. Oh, I'm so glad you asked that question. I just remembered that. I mean, we were gonna see the questions later anyways, but the unit of these guys have to match. So if the K is in seconds, the T has to be in seconds. If this is in minutes, this has to be minutes too. Yeah. This is going to be like a very easy question on your second midterm. Again, yeah. So, but again, remember, guys, I guess most people are just watching recordings and then kind of like go soft after the first midterm. A lot of you guys did very well on your midterm. Don't drop the intensity. It's like the second midterm will be 100% harder. 77% on for a class average is very high for this course. So, anyways, so the reason like this is actually a very helpful thing because a lot of times they give you the AT over A naught as a fraction of each other. Like they say, so tell me what time it's going to be like when, for example, your concentration is like a fourth of what it used to be, for example. That's what it is. So, and then for second order reactions, we use this one. So when y is equal to mx plus b, again, this one has a positive slope. So my m is actually plus k, and my b, again, this is 1 over a, so b would be 1 over a naught. So it would be 1 over at is equal to kt plus 1 over a naught. Again, in your thing, you see that all they do is that they bring it to the other side. It's the same thing. Again, I have told you this many times, like you can't rely on your formula sheet for like solving questions. You can double check, but when you don't know what variables go into the equations, you don't know what to look for in a question. Because it is literally my saying, is that if you know what to look for in a question, it doesn't matter how tricky the question and how the wording of the question is, you know what you need out of it. Yeah. So that's it. That's pretty much it. We're going to be doing like a bunch of questions on this. But before we do that, I'm going to actually introduce like I'm going to introduce like the equations for the half-lives too, and then we can actually practice together.